Okay, let's dive right into this. Welcome to today's Explainer. We are taking a highly structured, super strategic look at Cambridge IGCSE 0625 physics. And specifically, we're zeroing in on a crucial microtopic, measuring volume and density. Now, don't worry, we're not just going to sit here and recite dry formulas today. No way. Instead, we're using a powerful application-first approach. We're going to break down exactly how these concepts show up in real systems, how they actually drive calculations, and, probably most importantly for a lot of you watching, how to expertly navigate those tricky exam questions without just relying on blind memorization. It's going to be a game changer. Real quick, here's our roadmap for this explainer. We'll start with the volume density hook, move into the 4-step walkthrough, hit cause and effect physics, then look at real-life engineering applications, break down the exam success method, and finally wrap up with 4 vital memory prompts. This whole progression is designed to shift you completely away from rote memorization and toward a truly bulletproof exam strategy. All right, let's kick things off with Section 1, the volume density hook. So a truly strong physics study session, it doesn't start by just, slapping an equation up on a whiteboard. It starts by making the concept feel absolutely necessary. We have to establish why we even care about these measurements in the first place, right? So ask yourself, what physical effect, measurement, or prediction actually depends on understanding volume and density? Just take a second to really think about that. By leading with a provocative question like this, we're breaking that reliance on just memorizing words from a textbook. We're challenging you to reason your way through completely unfamiliar scenarios first, because, only after you understand the why should you even worry about the formal language. And honestly, this is exactly how you train your brain to adapt to literally any curveball an exam might throw your way. Let's move to Section 2 and see how this builds. This is the 4-step walkthrough. Okay, so understanding volume and density is really like a gateway into a much bigger scientific pattern. To truly master it, you want to follow these 4 linked steps. Step 1, identify the specific quantity or phenomenon you're dealing with. Step 2, state the relationship involved. Step 3, explain the underlying physics. And Step 4, connect it all to a real observation, experiment, or device. I cannot stress this sequence enthusiastically enough. It is your absolute secret weapon for IGCSE-style physics. The very best exam answers out there, they don't just prove you memorized a definition, they show deep understanding combined with real-world application. Moving right along to Section 3, Cause and Effect Physics. Now, this is the core mindset you absolutely need to adopt. When we talk about physics, we have to move gradually and deliberately from everyday intuitive language over to that formal physics vocabulary. This perfectly illustrates the concept of application-first physics. Basically, it means you always start with a concrete example. You only introduce a symbolic relationship, like, say, a formula or a really strict definition, when the physical reasoning is fully understood by your brain. Think about it like this. If a topic involves graphs, you actually need to understand what the slope, the area under the curve, the direction, or the shape mean in physical reality. They aren't just abstract math concepts, they represent real physical changes. So the crucial point here is summed up perfectly by this quote right from our source material. Insist on cause and effect rather than isolated facts. Seriously, whether you're looking at fields, forces, particles, circuits, or waves, relying on just a bunch of isolated facts, it's not going to secure you those top marks. You have to understand the chain reaction. You need the cause and the effect. Let's jump into Section 4, Real-Life Engineering Applications. Let's completely step out of the textbook for a second here, because these ideas around volume and density, they don't just exist on paper. They are literally everywhere. Take a look at these applications. We've got engineering and safety, transport and energy systems, communications, medical tech, and even astronomy. As a student aiming for true mastery, you should always be able to name at least one real situation from this list where volume and density actually help us predict or improve outcomes. I mean, knowing how density dictates the buoyancy of massive transport ships, or how volume relates to pressure in energy systems, that's the kind of thinking that bridges the gap between just being a student and becoming a real scientist. Okay, Section 5, the exam success method. Let's talk strategy. Keeping that real-world context fresh in our minds, let's put on our exam lens and look at how to translate all this rich physical understanding into maximum marks on your actual paper. Now, what's really interesting about this comparison is how starkly we can contrast failure with success. Look at these common weaknesses. Maybe you write down the correct formula, but you fail to explain what the variables actually represent. Or you quote a process, but you don't link it to a physical effect. Even if you give an example, if you don't show why it follows from the physics, you're going to lose marks. So to counter these traps, you need the safest method. And that simply means tightly connecting your reasoning directly to the structure that examiners are actively looking for. And here is that blueprint. This is the whole shebang, your ultimate method for securing marks in short answer and structured questions. 1. Definition. 2. Relationship. 3. Explanation. And 4. Application. If you filter every single exam answer through this 4-step framework, you guarantee you aren't leaving any easy marks on the table. You're defining the terms, you're showing how they relate, explaining the actual physics, and then applying it directly to the specific question they asked you. It's an incredibly robust system. Let's bring it home with Section 6, 4 vital memory prompts. So understanding the material is the first half of the battle, right? But retention, actually remembering it under pressure, that's the second half. When you're revising volume and density, or honestly any physics topic, ask yourself these 4 vital questions. What is the core idea? What changes physically in the system? What quantity or graph shows this change? And where is it used? Our source is super clear on this. If you can answer these 4 revision prompts out loud, your grasp of measuring volume and density is securely locked in for test day. I'm going to leave you with this final, slightly provocative challenge, pulled straight from the mindset of actual exam questions. Can you explain the physics behind measuring volume and density using a clear cause and effect chain right now? Seriously, don't just picture the formula in your head. Think about the application, the physical reality, the relationships. Test your newly acquired application-first mindset today. Thank you so much for joining me for this explainer, and keep questioning the physics of the world around you. Catch you next time.